All right. So with the feed the plant paradigm and the use of soil tests, we can actually calculate how much nitrogen we need. We know that, for instance, our anhydrous ammonia is 60 or 63% nitrogen, and then so we can calculate how much we need because we know that we need 110 pounds for our corn, for our acre of corn. So we can go through the math and calculate all that. But why not just go with a different idea? So in the feed the soil paradigm, you got this idea about let's just go to balance. Instead of saying that we're deficient in nitrogen, so we're overcompensate on the nitrogen, but then we may be deficient in the phosphorus or the potassium. We may be deficient in micronutrients, et cetera, et cetera. So then we go over this way. And we're going back and forth, we're overcompensating. Let's go to balance right from the get-go. Let's make a balanced nutrient mix, a balanced soil amendment mix, and let's just use that. And over time, very slow time, we're going to get our soil balance too. Especially if we integrate cover cropping, green manure, rotation, et cetera, et cetera. So, what I do is I look at different people who have experience. Like Steve Solomon, he wrote this book, Growing Vegetables West of the Cascades. He's sort of the Elliott Coleman of the West Coast. And Elliott Coleman is sort of the Steve Solomon of the East Coast. And then Solomon also wrote a book called Gardening Uncounted. Very good book. The whole point of this book is, what are you going to do when you don't have any oil, and in fact you can't get much water, and you can't get to town, and you've got to grow food? Well, here's what you do. And he's all about small plots, using hand tools, spacing your rows farther apart, basically dry land farming. Very good book. And so I use.
What's it called again?
It's called Gardening Uncounted.
Counts.
Yeah. And so he came up with this idea. Steve Solomon's an interesting guy. He started a territorial seed company back in the 70s, and then he lived in southern Oregon for a while. Then he ended up moving to Tasmania, where he lives now. He also does the Soil and Health Library, and you can go and you can get these old books like Plowman's Folly and Albert Howard's books and stuff like that, and you can download them and read them and get an e-version. But his idea is, here's a recipe that works. So with the Feed the Plant, we have this tailored calculation. And when I was in ag class in 9th grade, we used to do this all the time. And you calculate how much you need, and so here's your mix, and this, how much of this, how much of that. It's real simple. It's basic algebra. You just need a calculator. We also did the same thing with our animal feed too. So it's real simple. It just takes time. Now, and a lot of the researchers are all, you read them on the web and they say, oh yeah, the recipe idea is terrible, terrible, terrible. You've got to actually calculate this, and it changes from year to year. And it's different for what crop you grow, and you have to fit it into crop rotation. So, for instance, you want to make sure you have enough soil moisture, and so it can all be used, and make sure you have enough lime and all this. It's just you drive you nuts. Okay, so you just take this recipe here, modify it for your uses, and then try it for a few years. Works great. So what we have here, for instance, on the back, I have two examples. One example is with cottonseed meal as a seed meal, the other one is with soybean meal. So we got 50 pounds of cottonseed meal. It's at 5:1. Those three numbers are NPK. So we take 50 times 0.05, add that to 10 times 0.03, and we get a certain number. We divide it by 70 because we have 70 pounds here. And what we come up with is 4%, or 4.0. We do the same thing with the phosphorus level, which is the middle number. We do the same thing with the potassium level, which is the third number. And what we come up with in the example 1 is 4.0 for nitrogen, 3.6, these percentages, 3.6 for phosphorus, and 2.5 for potassium. Or in other words, rounding it up, it's a 443. Now you've probably seen, you go into the hardware store or the feed store, and you see Scott's fertilizer mix, and it's 10-10-10. Well, that's a balanced mix, but it's too heavy. So when we're dealing with organics, we want to have a mix that's down in the level of 4 or 5, something like that. So example 2 is using soybean meal, and you get a 534. And it's real simple. You can check that out, and that's the way that we take our recipe, then we use the methods of the feed the plant paradigm, and we actually check what our numbers are. And we see that yes, we have plenty of we have a nice balance, and we have plenty of phosphorus, we have plenty of potassium, we have plenty of nitrogen, and the value of taking the recipe first and then just checking it by the other method is that we're actually looking at what our inputs are. So Steve Solomon, for instance, is big on kelp meal for potash. I like green sand. Elliot Coleman is big on green sand. The potash, or I mean the green sand and the kelp meal are both products of the sea, so they have lots of trace minerals. The kelp meal comes from kelp. The green sand is an old ancient seabed in New Jersey, and they just scoop it out of the ground and bag it up. Langbeinite is another one. It's sometimes marked under K-mag or sulfo-mag, and that has sulfur, potassium, and magnesium. And that is 0022, for instance. I believe I have it down here. Sulfo-mag, yeah, 0022. So that's a real good shot of potassium, and that comes from an ancient seabed in Utah. And you scoop it up and they process it a little bit. It's minimal processing. And remember that organic basically is, natural, mechanistic approach, like very minimal processing, certainly not chemical processing, and slow acting. So what you can do here is you can use that recipe approach, put more stuff in the soil, and it's there, and it's not hurting anything, and it's there when your plants need it. Now the value of using something from the sea is that you get the trace minerals, and it's really important to get these trace minerals. When I grew up in the farm, you used to be able to get, we always put a salt block out for the cows, out in the pasture. And we always used to get the red ones, which have trace minerals in it. And most of the neighbors, they use the white ones, which are just salt, because they're too cheap to pay the extra 25 cents. Well, okay, that's, where I come from, it's pretty penny wise, pound foolish. They're old Norwegian farmers, and they're, and when they don't have, snooze drooling down their chin, they're drinking whiskey and they just don't think. They're penny wise and pound foolish. So they don't want to spend the extra 25 cents when actually getting some trace minerals in their cattle gives you more milk. Okay? And also, when you have the trace minerals, you're putting that in your soil, you're feeding your soil, your potatoes, your corn, everything will have a higher value of trace minerals. And so now, with my potatoes, after feeding my soil for a few years, I can cook them without salt. Don't need any salt on them. They're just fine. They taste great. So, once again, we're looking at what are our results. I feed the soil, I get great results. You look at what industrial agriculture is doing, feed the plant, we're in big trouble. Okay? Real simple. Start at the paradigm level, change your thinking, and we'll do better. Especially since the feed the soil paradigm works in very well with small scale agriculture.
What do you think of calcine?
Calcine? I don't know that one. Is that
It's from some kind of salt deposits from the sea that used to be there.
Great. Well, it probably has, and it probably has a lot of trace minerals, yeah. So you want to, when you have something that you're not sure of, you want to just use a little bit and then see it. Well, now all this stuff takes time. You don't get instant results, and that's another problem with the feed the plant paradigm is that they want instant results. They want to go in there in the fall and put a little lime down. They want in the spring they want to put a lot of chemicals in, and they want instant corn crop. Whereas with small scale agriculture, feed the soil, it takes years and years and years. You've got to observe what you're doing.